Hello everyone, my name is Jan and I'm software engineer at Google where I've been working on an open source project called gRPC for the past 3 years. In this talk, I wanted to provide a retrospect on how gRPC went from the first line of code to a popular GitHub project. And along the way, I would like to share three things. First, what were the challenges we faced over time, what we've done to resolve them, and also what were the lessons that we learned from that. I'd also like to point out that I'm by no means an expert on open source project leadership, and this talk is based mostly on my personal experience and opinions as an engineer on the project. So feel free to disagree with anything I say. I guess a lot of you have already heard of gRPC, but just in case, I'll give a quick overview what it's good for. As the name indicates, gRPC is a library for making remote procedure calls, and here's the idea. Let's say you have a server and a client, and you want them to send RPCs between each other. That, of course, is a pretty old concept, but it starts to become more interesting as you add additional requirements. So first, you'll definitely want to have an easy way to define an API for your RPCs. That basically means what will be the methods and what will be the arguments. Once you've defined the API, you realize some of your clients or servers are better implemented in a different language or on a different operating system, but of course they still need to interoperate seamlessly. Next, you probably don't want to be wasting network resources, so you want the data to be efficiently encoded on the wire, but your API still needs to be easily extensible. And as your application grows, you'll probably find yourself needing to do thousands of RPCs per second. And you probably want all the communication to be secure. gRPC gives you all of these and a lot more, and its goal can be stated that it's trying to make interconnected components in distributed systems simple for everyone. So that's great for the users, but here's the problem. Usually when you take something that's inherently complex and you try to make it simple for others, it means that you will be the one solving the problem. And because RPC libraries are a hard problem and gRPC is pretty versatile, we've had to solve a ton of difficult problems over the course of our project. And it was actually many more than we have time for today. So the way I'm gonna do it is I'll first walk you through the main development stages in gRPC's history, and later I'll pick one or two most interesting challenges for each of the stages. gRPC as a project started approximately 4 years ago, but for the first year, the code lived in Google's internal code repository. In this pre-open source phase, we defined the vision for a universal RPC framework. We designed the wire format, or gRPC's protocol, if you want, and we also created the initial implementation. And we were also preparing for the open source launch. Then, beginning of 2015, we migrated all the code to GitHub, and in February that year, we made the repository public, launched the project website, published a blog post, and that was pretty much the open sourcing of gRPC. We started with a basic RPC functionality in 5 languages. Those were C++, Java, Go, Ruby, and Node. And the remaining languages, Python, C#, PHP, and Objective-C, reached the same bar within the next few months. The criteria for this so-called alpha version were to support simple and streaming RPCs, along with some basic documentation and examples. After delivering the basic experience in all languages, gRPC had two main objectives to reach the next milestone. First, we needed to give users a fully featured RPC library, and so we added support for RPC deadlines and cancellation, and we also provided full support for RPC metadata. And secondly, we wanted to make sure users can use gRPC without risking they'll need to rewrite their code in the future, so we made all our APIs stable. Besides these, we also added some extensions like server reflection or health checking, and we launched beta in September 2015. The next release was basically about stamping the entire product as production ready. We focused a lot on stability, addressing user issues, and testing. As part of our testing effort, we also started to continuously measure gRPC performance and made some significant improvements in the performance itself. And we realized that our installation process was way too complicated. So we invested a lot of effort into providing a simple one-line install in all the languages. Overall, it took almost a year to make gRPC generally available, and we released in August last year. After the first stable release, we worked on advanced features like load balancing, tracing, retries, or service config. But we also continued to work on performance and usability improvements. To ensure gRPC fits well into the larger ecosystem around cloud distributed systems and microservices, gRPC got donated to the Cloud Native Computing Foundation. So since March 2017, we are sharing home with other popular open source projects like Kubernetes, Prometheus, OpenTracing, and some others. So this was gRPC history in a nutshell, and I'll now rewind a bit and tell you more about the difficulties in each phase. So we're now back in the pre-open source phase. The most important part of each project is coming up with the right vision, and it's clearly the most difficult part as well. At the beginning, there were basically two separate RPC worlds at Google. First one was services in data centers communicating through an internal RPC library, which is called Stubby, by the way. And then there was a whole separate world of user-facing APIs, which means external customers talking to services running in a data center using public REST APIs, and their HTTP JSON requests need to be translated by proxies along the way. So that's how things have traditionally been, but both these worlds actually do have a lot in common. And the key idea was perhaps they should be joined into one. From there, it was still a long journey to define an actual plan, but the way it happened was that a few very experienced engineers from the internal RPC world and a few also very experienced engineers from the API world sat together at one table and they iterated on the initial idea. And eventually they were able to come up with a technical solution that unifies both the existing worlds in a way that made a lot of sense. And that's what later became known as gRPC. I don't think there's a magical recipe how to come up with a project vision, but in gRPC's case, there have been definitely two key ingredients. First of them is you need to find great people who have deep understanding of the area they're working on, and this part basically will guarantee that the vision they come up with will be feasible. And secondly, you need to connect people from different areas of expertise together because that increases the chances that they will come up with something new. Besides the vision, there was also, of course, also a lot of coding, designing, and improving the wire protocol, and a little bit of talking to lawyers before everything was ready, and we moved all the code to GitHub, and we were ready for the initial open source release. Okay, so gRPC is now open source, and we have an implementation in 10 languages. Some of them are in better shape than others, and we are standing in front of two challenges. First, to define an APIs, or first to define APIs that are easy to use and feel natural in any given language. And secondly, all the languages need to have a parity in terms of supported features, and there also needs to be, let's say, common spirit for all the languages and APIs. That might seem easy, but it's actually much harder than it looks. We had about 20 people working directly on gRPC by that time, but because of our very broad scope, not everyone could be an expert on everything. Besides having several language experts, and those were different people for different languages, someone had background in high performance RPCs, someone understood the HTTP2 protocol really well, someone knew about mobile app development, and so on and so forth. And with such diverse setup, it's very hard to come up with a consistent set of 10 APIs and implementations that work well with each other. So what we did is we established a few main pillars that acted as points of reconnection. They gave everyone the freedom to work on things independently, but also provided a way to check that their work is aligned with everyone else's and to guarantee everyone will be on the same page eventually. For API design, we set up a process where every language had an API design document based off of a common template. The template defined approximately 10 scenarios based on common use cases, and then every language owner came up with an API proposal and wrote a short snippet of code for each scenario, usually with some explanatory comments. We then shared the document with a panel of 5 language experts outside our team and iterated on the design until everyone was happy. We found out that it is much easier to reason about the examples and code snippets than about sometimes complicated language constructs. And the common structure of the document also made it easy for people working on other languages to check for consistency and correctness of their work. In terms of functionality, we've set up so-called interoperability tests. It's basically a set of 20 simple scenarios that are implemented in every language, and we started running them for all possible language combinations. In this initial phase, we use them to evaluate whether a language implements given functionality correctly. And later on, we caught a lot of cross-language issues with these tests. So these have proved incredibly useful. After we implemented all the required features and after polishing the APIs to a state where we felt comfortable freezing them, we felt that the gRPC usability jumped to the next level, and we released the beta version in September 2015. After the beta release, we had 3 objectives to become production ready: stability, performance, and features. But instead of talking about these objectives separately, I'll only talk about testing because it has a significant overlap into all these. and it's also a prerequisite because without reliable testing infrastructure and tests that are passing, it is pretty hard to achieve any of those objectives. In order to understand why testing poses such a big challenge, you need to know that the gRPC nature makes it really hard or makes it a really difficult project to test. So you already know we have 10 languages and we need to test on 3 operating systems. But because we're an RPC framework, a lot of our tests are actually using network and are time sensitive, which makes the testing more complicated. And sometimes there are tests that are failing, but they're not failing in 100% of time. So that's hard to manage. We also have many different kinds of tests. We have unit tests, integration tests, portability tests, and each of these categories requires something a little bit different and requires a little bit different setup. A lot of our code is also a multi-threaded concurrent code, so oftentimes we run into bugs that are hard to root cause or even reproduce, and to some tests we can be running them for a while and not see the issue at all. We also have a extremely large test load. So for every change, we run hours and hours of tests, and that's becoming harder as we have a lot of developer traffic as well. So we basically have a lot of contributions coming into the repository at any given time. So even though there are many managed testing solutions out there like Travis or AppWare, which are otherwise great by the way, it quickly turned out that for us they are insufficient in terms of capacity, platform support, and all the kinds of test setups we needed them to support. So we actually built our own testing solution based on a continuous integration server called Jenkins, which was orchestrating a lot of VMs in the cloud. And we spent tons of time setting it up and maintaining it. This custom solution was actually in use until very recently. And over those 2 years, we learned these lessons. And sometimes we learned them in a hard way. The quality of your automated testing infrastructure actually matters much more than you would think. If it's easy to get the test results, it doesn't take too long since the time the test started, and the tests are presented in a readable way, developers will be much happier and productive. And you can guess what happens if things work the opposite way. So also for these reasons, I think it's a good idea to use the managed testing solution like Travis or AppWare if you can. And it's actually almost to a point that it's sometimes fine to adjust your project so that you can actually use these tools and you can benefit from them. You shouldn't try building your custom testing solution unless you absolutely have to. It's a much harder business than what it looks like, and I can guarantee you'll spend tons of time maintaining and troubleshooting things that have nothing to do with your core business. This also applies to things like writing your own custom test runners and similar things. If you happen to have broken tests in your project, it's really important to fix them as soon as possible, because and the reason is not because those broken tests are decreasing the project quality that much, but it's actually the impact it has on people. So even with great engineers on the team, people are just people. So if a test stays broken or flaky for some time, uh, people will lose track which tests are broken and they'll stop paying attention. Uh, and eventually more stuff will be broken. And this is uh, this is how the whole cycle continues. And I like to call it a vicious cycle of broken tests. Another interesting experience we had is that we've actually built some test frameworks that we later threw away because they were too complicated, and we actually never caught any bugs with them. So one good example is our stress testing framework, which you might remember if you've been following the project for a while. So uh, I think a good approach is to, whenever you're introducing a new kind of test or a new testing category, to make sure that the tests kind of prove themselves and you can actually see that they're useful uh, before you invest a significant effort into improving them and maybe including more languages and doing things like that. Um, Besides that, it's also very important to collect data about your tests because if you're not a small project, uh, you probably have a lot of tests running, and at some point it becomes impossible to track which tests are getting broken when and what are the most flaky tests currently. So having a data that you can use to get these results is actually really helpful when trying to improve your project's test health. Uh, we actually download our data to BigQuery, and then we can run simple queries to analyze what's going wrong when tests are getting broken. So I'll jump back to the point where we have a production ready RPC library, and after reaching that milestone, um, I'm sorry. So until reaching that point, it was pretty much clear what needs to be done because most of the adopters were basically waiting for the same thing. But after reaching GA, things became a bit more diverse, and it started to. It was also a good time to start putting more effort into making sure that the users are being heard. So staying in touch with users actually happens on two different levels. Either it's things of a smaller scope, like issues in issue tracker, pull requests, and questions in forums, but there are broader scope things like plans for major changes and introducing new features. Uh, I'm gonna talk about both, but I'll start with some experience we had with handling user issues and questions. For any popular project, the issues and forum questions from users tend to arrive at a pretty high rate. And because they are not always easy to address, they can quickly accumulate. And before you know it, the project ends up with a high number of unresolved items. The number of open items is actually not a problem. You'll notice that most successful projects of sufficient size tend to have a relatively high number of them. So as long as you don't get lost in those and you stay responsive to the newly incoming stuff, you'll be doing fine. In a larger team, it can become difficult to ensure newly added items get noticed by the right person. And you also can't have everyone constantly watching all the channels because they wouldn't be doing any work. And everyone probably knows that when a software engineer gets into the coding flow, they really don't want to be distracted. So We set up a weekly rotation where a few engineers go through the latest issues in GitHub, mailing list, and Stack Overflow, and they assign engineers with the right expertise, uh, and those are supposed to come up with a meaningful response until next time the office hours happen. So we found out this model actually works pretty well, and over time we realized a few more things about user behavior. More often than not, users don't include sufficient information when filing uh, issues in the issue tracker. And not knowing which platform, what version, or not seeing a stack trace, uh, you're not very likely to be able to help. And back and forth to gather all the info is a distraction for everyone. So GitHub actually allows you to set up a default text for newly created issues. Um, and in there you can point out what information is important for you. Our template is basically a short questionnaire. Uh, this also acts as a filter for users that genuinely want to work with you. Because if someone's not willing to answer 5 simple questions to get help when filing the issue, uh, trying to help him is, or her is probably a waste of time anyway. On the other side of the spectrum, there's a group of users that are asking meaningful questions and are very cooperative when debugging, and working with them is, of course, time well spent. So, because you know them and they know you, they'll start emailing you directly because they already know that you happen to understand this particular topic, and it seems to be the most productive way to solve their issue. And in a way, it is, but in the long run, I think it's not the best way because chances are other users will have the same question sooner or later. So you either need to respond to those questions again, um, or you try to figure out how to rip out the right information from your personal email to uh, get them the response they need. And both of these are actually pretty demotivating and they're a waste of time. So, as an open source developer, your time budget to work with the users is always somehow limited, and you should make sure that every sentence you write will benefit as many users as possible, which means that all your communications with users should be public. Another problem you might encounter is that you see the same trivial question over and over. To some extent, that's normal because users don't have the same context as you do, and obviously, some of the basic concepts aren't as clear to them as they are to you. But it's always a good idea to check if there's a way you could improve the documentation so they so things are clear for everyone and no one has to ask. Last but not least, no matter how hard you try, you won't be able to make everyone happy. So you'll need to learn how to say no politely without feeling guilty. It also helps to work on your criteria. Oh, sorry. It also helps to work on your project rules and contribution guidelines because saying your contribution doesn't match our criteria that are described here and there, uh, it's much easier than to say, I don't like your contribution then. obviously it's also more digestible for the other person you're talking to. So until now, I was talking mostly about the smaller changes. In terms of larger changes, we really wanted to give our users the opportunity to express their opinions, uh, create their own proposals, uh, or at least be informed about what's planned. So we created a proposal process. The proposals lived in a gRPC proposal repository, which also contains a detailed description of the process. But the idea is you create a proposal, and they are divided into several categories, and then there's a review process, and eventually, if the proposal gets merged, that basically means your proposal was accepted, and there's probably going to be more work on that. I already mentioned that gRPC got donated to CNCF to stay aligned with other popular projects. Besides that, we also have our own ecosystem that lives in GitHub and is for software that's directly related to gRPC. Uh, and if you look there, you can basically see projects like gRPC enhancement, proxies, tools, integration with other projects, and so on. So I think that's been enough about history, and I'll now jump to the present day and show you some data about how gRPC is doing. This is a chart of how many stars we have on GitHub in each of our 3 GitHub repositories. The star count is a rough approximation for project popularity on GitHub. And as you can see, gRPC is alive and well. And we've been growing with a pretty steady pace, basically from the beginnings of the project. To date, the total star count over gRPC, gRPC Java, and gRPC Go is almost 20,000 stars, which is actually pretty good compared to other popular projects. By the way, if you see the steeper part of the chart around August 2016, that's actually our production release. In terms of who's using gRPC, we also seem to have a growing user base. By the way, because we are an open source project, it's pretty hard for us to know who's using gRPC unless the users tell us themselves. So if you're a gRPC adopter, please let us know, because we definitely like to learn more about our users, and we are always open to feedback. And with that, I'd like to thank you all for your attention, and I'm ready to take questions.